Hello students. So we will be now dealing with slider crank mechanism. So slider crank mechanism, we have already done a video on 4-bar mechanism or 4-bar chain. So basically there are three kinematic chains you want to learn or they are important for our scope of study. First one is 4-bar chain, second one is slider crank chain, and third one is double slider crank chain. So we will be dealing with slider crank chain in the chain in this video, and we have already dealt with 4-bar chain. So we will just review what we have learned about 4-bar chain, and we don't need actually to learn in detail about double slider crank chain for this subject or scope of the study for now. So we'll just see how 4-bar chain has been inverted and what were the inversions that we learned for 4-bar chain, and now we will study what is a slider crank chain. So first, just to review what we have learned in 4-bar chain. So in 4-bar chain, we learned that 4-bar chain is a mechanism having four links. If you remember correctly, four links with one of the links fixed. So grounded link, second link, first link, fourth link, and third link. And if you apply a torque on to second link, fourth link will be the follower, and first link will be the driven link. So we also learned what are the different inversions. Inversions means fixing different links to achieve different kind of mechanism from the basic mechanism. So first inversion was a coupled locomotive, and second inversion was beam engine, third was pantograph, fourth inversion was watt mechanism or Watt's indicator mechanism. So we will just review what we have learned in 4-bar mechanism. So this was our basic 4-bar mechanism. So in 4-bar mechanism, there is a crank or driver, there is a follower connecting rod, and this is how a 4-bar mechanism works in a clockwise direction. When you apply a torque in the second link, then the 4-bar mechanism rotates, and blue one is the fixed link. And this is a side view that is going to happen, three-dimensional view or isometric view, you can call it. Then we will see the first inversion of the 4-bar mechanism. First inversion was coupled wheel locomotives or coupled wheel. This is the connect coupled rod, that is the link 3. There is a fixed link behind those wheels, like here. Yeah. So that is the first inversion of 4-bar mechanism. We already learned that in few sessions back. Coupled wheel locomotive. This is basically used in locomotives in earlier times. Still it is used sometimes. Coupled wheel locomotive. Then the second inversion was beam engine. So second inversion is beam engine. Beam engine is basically a oscillating rod is there. There is a connecting rod. There is a crank, and this was the second inversion of 4-bar mechanism, which is known as a beam engine. This is basically used in very deep bore wells or in oil rigs. You can still see it in some US, Las Vegas, and Nevada desert, so where they dig oil or they mine oil, natural crude oil. Third inversion was a pantograph. That is basically a magnifying mechanism. So if you trace a point in that connection of those two red dots here, you will get a magnified image in the outer one, that is here. And the fourth inversion was a Watt's indicator mechanism. So if you have studied, you know what is Watt's indicator mechanism. That means it will trace a indicator diagram of a object moving. So this is Watt's indicator mechanism. So we'll just skip it through. Now we will come to what is known as slider crank mechanism. Slider crank mechanism or slider crank chain. It also has four inversions. We will study the inversions later. First, let us see what is a slider crank mechanism. So slider crank mechanism is actually a modification of a 4-bar chain. I'll just show you a basic 4-bar chain. So this is a basic 4-bar chain. Let this link 1 is fixed, 2, 3, and 4. So in 4-bar chain we have all 4 pin joints and all 4 turning pairs. So this link and this link turns, this link and link turns, these two turns, these two turns. So all forms a turning pairs. So if you replace these two links turning pair with a sliding pair, you will get a slider crank mechanism. That is replacing one turning pair of a 4-bar mechanism with a sliding pair, you will get a slider crank mechanism. That is the definition, or that is how you get a sliding pair slider crank mechanism, replacing one turning pair of a 4-bar mechanism with a slider pair or sliding pair. You see, first link is, second link is, third link is, and this turning pair we, this for fixed link and fourth link turning pair, that we replace, this turning pair we replace with a sliding pair. This is a turning pair, we replace it with a sliding pair, and you will get a slider crank mechanism. So slider crank mechanism basically has 4 components. First one is a crank which rotates about a joint here, so it forms a turning pair. Then you have a connecting rod which is connected to crank at one end, another one at a crosshead, or you can call that crosshead as a piston. So that one also rotates about the crank. Then you have a piston, and instead of the fixed link being a turning pair, we have a piston sliding across this fixed link. This is the fixed link that we call as crosshead guide, or in your local and for better to understand, you can call it as this as cylinder walls and this as piston. Like you see in an IC engine, you can call this third link as a piston and the fourth link as a cylinder walls. So fourth link is the fixed link. So you can draw it on the other mirror image also. So this is a crank. This is a, so when you draw it, it is better to draw the axis first. So horizontal axis. Then you draw a circle by which the crank rotates. Then you draw a crank. Then connecting rod. Then a piston and a cylinder wall. So this is a slider crank mechanism. And since a circle is not part of the diagram, we can put it in dotted lines. So here is a pin joint. You should mark the joints of the, this is a pin joint. Here it is another pin joint. There is another pin joint. And this forms a turning pair. This forms a turning pair. This forms a turning pair. And this one forms a sliding pair between piston and the cylinder. So naming the links, crank is the first link, connecting rod is the second link, piston or the crosshead is the third link, and cylinder walls or the crosshead guide is the fourth link. So this is basically a slider crank mechanism. It is used to convert either rotary motion into reciprocating or reciprocating into rotary. That depends on where you use this mechanism. If you are using this mechanism in engine, we are converting the reciprocating engine of the piston inside the cylinder due to the burning of fuel to the rotary motion on the crank, which will be supplied to our wheels of automobiles. And if you are using this to in some machine tool operations that we will see later, in machine tool operations, this is actually used to convert the rotary motion given by a motor to the reciprocating motion supplied to the tool head, by which the tool cuts a machine surface. We will see it in detail. So this is basically a slider crank mechanism. So slider crank മെക്കാനിസത്തിൽ 4 ലിങ്കാണുള്ളത്. ഒരു 4-bar മെക്കാനിസത്തിൻ്റെ ഫിക്സഡ് ലിങ്കും ഫോളോവറും തമ്മിലുള്ള ജോയിൻറ്റിനെ സ്ലൈഡിങ് പെയറാക്കി മാറ്റിയിട്ട് കഴിഞ്ഞാൽ, അല്ലെങ്കിൽ ടേണിംഗ് പെയർ ആയിട്ടുള്ള ഒരു പെയറിനെ സ്ലൈഡിങ് പെയറാക്കി മാറ്റി കഴിഞ്ഞാൽ സ്ലൈഡർ ക്രാങ്ക് മെക്കാനിസം കിട്ടും. സ്ലൈഡർ ക്രാങ്ക് മെക്കാനിസത്തിൽ ഒരു ക്രാങ്ക് ഉണ്ട്, ഒരു കണക്റ്റിംഗ് റോഡ് ഉണ്ട്, ഒരു ക്രോസ് ഹെഡ് അല്ലെങ്കിൽ പിസ്റ്റൺ, ആൻഡ് ക്രോസ് ഹെഡ് ഗൈഡ് അല്ലെങ്കിൽ സിലിണ്ടർ വാൾസ്. ഇതാണ് 4 പാർട്സ്. ക്രാങ്ക് റൊട്ടേറ്റ് ചെയ്യും. ഇതിലെ സ്ലൈഡിംഗ് പെയർ എന്ന് പറയുന്നത് ക്രോസ് ഹെഡും ക്രോസ് ഹെഡ് ഗൈഡും അല്ലെങ്കിൽ പിസ്റ്റണും സിലിണ്ടർ വാൾസും തമ്മിൽ സ്ലൈഡിംഗ് പെയർസ്, ബാക്കി 3 ടേണിംഗ് പെയർസ്. സോ എ സ്ലൈഡർ ക്രാങ്ക് മെക്കാനിസം കൺസിസ്റ്റ് ഓഫ് 3 turning pairs and a sliding pair. In 4-bar mechanism, there were all 4 turning pairs, but in slider crank mechanism, we replaced one turning pair of 4-bar mechanism with a sliding pair. So we have 3 turning pairs and 1 sliding pair. Sliding pair is between 4 and 3. Between 2 and 1, there is a turning pair. Between 3 and 2, there is a turning pair. and between one and this joint there is another turning pair. So 3 turning pairs and one fixed, sliding pair. Yeah, and it is used to convert rotary motion into reciprocating motion or vice versa. Both are used. That depends upon where you apply it. So this is basic diagram of a sliding slider crank mechanism or slider crank chain. You can draw either this diagram or this diagram for your lecture notes. That depends on which is easier for you. But mark the each link correctly. So now we will see what are the inversions of a slider crank mechanism. Actually, there are 4 inversions, but we need only to go into detail of 2. And first inversion you can use it as reciprocating engine. First inversion is reciprocating engine. That is basically our IC engine, which consists of piston, cylinder, crank, and cutting rod. Second one is a hand pump. Sometimes it is also known as double slider mechanism, but hand pump is more than enough. Hand pump or pendulum pump also it is, but you don't need to study that. Hand pump, second inversion. Third one is known as the oscillating cylinder, and fourth one is known as Whitworth mechanism. But we need to concentrate on the other two, that is crank and slaughter mechanism and Whitworth quick return mechanism. We will concentrate only on these two inversions of slider crank mechanism. Others we will just see and skip it. You need to only draw and describe about these two mechanisms, crank and slaughter and Whitworth mechanism, because these two are used in machine tool applications. So we will just start with crank and slaughter mechanism. So this is a crank and slaughter mechanism. You can just see this one first, then we will go about the other one. So in crank and slaughter mechanism, there is a crank. This one is known as the crank. This is crank. And there is a slider. Slider is actually this one. This is the slider. Then this is an oscillating link. Oscillating link. And this one is known as a ram. And normally this is used in machine tool application. That will be a tool, cutting tool. That last point will be a cutting tool. That will be a tool. And this one is a fixed link here. So what happens is this slider rotates about this direction and you will move this ram to and fro. We will see how it happens. So we will see how a crank and slaughter mechanism works. So this is a slaughter bar, there is a crank, this is a slider, frame is fixed, there is a slider. Slider, at the end of that slider we will attach some tool. You see, forward motion is taking more time and we are returning quickly. So long time here, we are taking a long time to go here, but we are using very small angle to return back. Just see that again. That is not slider, that is another mechanism, sorry. Yeah, again crank and slaughter mechanism. So will take more time to go from here to here. So long time there, long stroke and a short return stroke. That is the idea of using crank and slaughter mechanism. That is why we use it. Forward stroke is long, whereas return stroke is quick. That means we will be cutting in a forward stroke and we will be returning in a return stroke. That is why we call it as a quick return mechanism. Again, slaughter bar crank. Just try to understand what is a crank and slaughter mechanism. So forward stroke is long. You see, a mechanism in which time taken for travel in return stroke is less than the forward stroke. Because the application of this comes in different machine tools. This application basically comes in a machine called shaper machine. So we will have a cutting operation in the forward stroke and we will be returning the tool idle in the second stroke. That means നമ്മൾ മുമ്പിലോട്ട് പോകുമ്പോൾ കട്ട് ചെയ്യും മെറ്റലിനെ, പിന്നിലോട്ട് വരുമ്പോൾ കട്ടിങ് ഉണ്ടാവില്ല. അപ്പോൾ നമുക്ക് കിട്ടുന്ന എനർജിയുടെ മാക്സിമം കട്ടിങ്ങിന് ഉപയോഗിച്ചിട്ട് റിട്ടേൺ സ്ട്രോക്കിൽ പെട്ടെന്ന് തിരിച്ചു വരും. അപ്പോൾ കട്ടിങ് ടൈം കുറവായിരിക്കും, അതേപോലെ കിട്ടുന്ന മോട്ടറിൻ്റെ എനർജി കൂടുതലും കട്ടിങ്ങിനായിട്ട് ഉപയോഗിക്കുക. അതുകൊണ്ടാണ് അതിനെ ക്വിക്ക് റിട്ടേൺ മെക്കാനിസം. റിട്ടേൺ സ്ട്രോക്ക് പെട്ടെന്നായിരിക്കും. 360 ഡിഗ്രിയിൽ റൊട്ടേറ്റ് ചെയ്യുമ്പോൾ അതിൻ്റെ ഉള്ളിൽ കൂടുതൽ ആംഗിൾ യൂസ് ചെയ്യുന്നത് ഫോർവേഡ് സ്ട്രോക്കിനും കുറച്ച് ആംഗിളെ റിട്ടേൺ സ്ട്രോക്കിനും യൂസ് ചെയ്യുന്നുള്ളൂ. അതാണ് ക്വിക്ക് റിട്ടേൺ മെക്കാനിസം. യൂസ് മുമ്പിലോട്ട് കൂടുതൽ സമയം പെട്ടെന്ന് തിരിച്ചു വരും. അതായത് ഈ റൊട്ടേഷൻ്റെ കൂടുതൽ ആംഗിൾ യൂസ് ചെയ്യുന്നത് ഫോർവേഡ് സ്ട്രോക്കിനാണ്. ദിസ് ഇസ് നോൺ ആസ് ക്രാങ്ക് ആൻഡ് സ്ലോട്ടർ മെക്കാനിസം. സോ യു സി ടൈം ഫോർ കട്ടിംഗ് സ്ട്രോക്ക് ബീറ്റ ആണെങ്കിൽ റിട്ടേൺ സ്ട്രോക്ക് ആൽഫ ആയിരിക്കും. ബീറ്റ എപ്പോഴും ആൽഫേനെക്കാട്ടി കൂടുതലായിരിക്കും. കട്ടിംഗ് സ്ട്രോക്കിൻ്റെ ആംഗിൾ എപ്പോഴും കൂടുതലായിരിക്കും. സോ ബീറ്റ ഗ്രേറ്റർ ദാൻ ആൽഫ. സോ ബീറ്റ ബൈ 360 മൈനസ് ബീറ്റ എന്ന് എഴുതാം, അല്ലെങ്കിൽ 360 മൈനസ് ഒരു ആംഗിൾ അറിയാമെങ്കിൽ മറ്റൊരു ആംഗിളിൽ 360 മൈനസ് എന്ന് എഴുതാം. സോ നിങ്ങൾക്ക് ഈ ഡയഗ്രാം വരയ്ക്കാം, അല്ലെങ്കിൽ ഈ ഡയഗ്രാം വരയ്ക്കാം. സോ ഇതിൻ്റെ ആപ്ലിക്കേഷൻ വരുന്നത് ഷേപ്പിംഗ് മെഷീൻ എന്ന് പറഞ്ഞൊരു ഒബ്ജക്റ്റ് മെഷീനിലാണ്. നമുക്കത് കാണാം. We'll see how the application of crank and slaughter lever mechanism comes in a shaper. This is a shaping machine. This is available in our lab. So we will be cutting an element here. You see that is a cutting operation happening in the forward stroke, and it is returning without cutting. So we are using more energy to cut the element, cut the metal in the forward stroke, and we are using less energy to return the tool to the starting position. This is a shaping machine operation. We will be using you see the crank and slaughter mechanism working in this area. Crank and slaughter mechanism. So that is how the crank and slaughter mechanism works. This is known as a shaping machine. This is available in our lab. You will be doing the work experiment with this shaping machine. So forward stroke is a cutting stroke that takes a lot of time. That means that is more energy given by the motor is utilized for cutting stroke, and will be returning quickly. So that is known as quick return or crank and slaughter quick return mechanism used in shaping machine. Now we will see what is a Whitworth quick return mechanism, which is also a quick return mechanism derived from the slider crank chain. Here this is a basic view of quick return mechanism. Instead of a crank and slotted where it is happening vertically, quick return mechanism happens, the ram position is changed. You see the difference between the two. This is crank and slotted, and this is Whitworth quick return mechanism. So here also there is a crank. Here the crank was pin joined at center of the circle and one at the oscillating link. Here center of the circle is here, but the oscillating cylinder is oscillating link is not at the periphery of the circle, but it is inside the circle. Here you can see the sliding was happening in the periphery of the crank rotation circle, whereas here it is happening inside that circle. And this is also another one used in machine tools. This also have the same kind of quick return mechanism. We will see how the machine operates. So this is another rotation, that is quick return mechanism. So this is how the quick return mechanism works. This is used in basically a machine called a planing machine, in which actually tool does not move, workpiece moves. In shaper actually tool moves over the workpiece. Here it is actually workpiece is actually moving. We will see how it moves. This is the quick return mechanism. Again forward stroke is long, return stroke is less. We'll just compare it with this was a crank and slaughter mechanism working. Crank and slaughter, and this is quick return. You see the difference? Crank and slaughter used in slotting machine. This is quick return mechanism used in Whitworth quick return mechanism used in planing machine. Both are quick return mechanism. This is known as crank and slaughter mechanism, and this is known as Whitworth quick return mechanism. I hope the animation clearly defines how the machine works, and we will see how a planing machine works using this mechanism. So this is a planing machine. In the planing machines are used to cut very large work pieces. Shaping machine are used to cut very small work pieces where tool moves to and fro to produce the cutting motion. In planing machine generally used for producing flat surfaces in very large workpiece. So here tool does not move. This is the position of the tool, but tool does not move, whereas workpiece moves. That Whitworth quick return mechanism The second one we learned, Whitworth quick return mechanism is used to move this workpiece. This is the workpiece. Tool is fixed, but workpiece moves. Now we'll see how the workpiece is securely and moves in front of the table. You can just see that if what is a planing mechanism. You need not study the machines. You will study it in MTDM or in AMT, but you should understand where the quick return mechanisms are operating. Tool is fixed in the tool head, and that is a workpiece. Workpiece moves, and we will see how. You see, workpiece or the table containing the workpiece is moving to produce the cutting stroke, and it will be returning quickly. This is applied by using Whitworth quick return mechanism, used to move the workpiece of a planing machine. Whitworth quick return mechanism used to move the workpiece of a planing machine. This is how the planer works. Shaper, the tool moves. In planing, the workbench or the workpiece moves. Again, you see, tool stays there, workpiece moves. We will just overview what was slider crank mechanism. First inversion is basic IC engine, in which cylinder will be fixed and a piston will be rotating, reciprocating inside. This is the first inversion. Cylinder is fixed. That we call it as reciprocating engine. Input is a reciprocating motion and output is a reciprocating compressor. And second inversion is we will fix the connecting rod and we will get a crank and slotted quick return mechanism. QRM means quick return mechanism. Crank and slotted is the best quick return motion mechanism. We already seen what is a quick return motion mechanism. And third one is a hand pump that we will see later. This is a hand pump. We will see the animation of that. We are not concerned about that now. Now we will see how to draw a crank and slotted mechanism. You see, first there is a fixed link. Then there is that oscillating link. Crank rotates around a circle. There is a slider. Then the motion of that oscillating cylinder, maximum motion possible. There is a connecting rod, a ram, and that is the return angle alpha, beta, which is the working angle. So beta will always be greater than alpha. That is how you draw a quick return mechanism. That is the maximum position. This is the minimum position. Now we will see how to draw the Whitworth quick return mechanism. This was crank and slotted. This was Whitworth. Crank and slotted is used for shaping, shaper mechanism where tool moves. This will be the tool. And in Whitworth mechanism, actually workbench or workpiece moves used in planing mechanism. Again, this is the work cooker. The fixed link is there. That is a fixed link. Then we will see crank, slider, oscillating link, the circle around which oscillating link moves, and then this. In quick return mechanism, this is actually connected not to the tool but to the workpiece of the planing machine. So this is how the quick return mechanism works. And that is alpha, which is the return angle, beta is the actual working angle. Okay. That will be okay. So now we will just see what are the other inversions of slider crank mechanism, which we need not go into detail, but still we should learn the names of that. This is basic slider crank mechanism. Basic slider crank mechanism. One of its inversion is hand pump. First inversion was reciprocating engine that we see. First inversion was slider crank mechanism, or what we call it as reciprocating engine. There is a cylinder, there is a piston inside the cylinder, connecting rod rotating around the crankshaft, shown in black color. That is reciprocating engine. Second one is known as hand pump. Second inversion is known as hand pump. We all have seen hand pump in our childhood days. Still, there is some where this is used. This is also an inversion of reciprocating, slider crank mechanism. Hand pump. You can see piston closes the footwall. You know how the operation of hand pump is. When you compress, the footwall closes. When you expand or pull up, the footwall opens and takes in the water up from the deep bore hand pump. That is also an inversion. We are not going into detail about hand pump. Next one is known as oscillating cylinder engine, which is another inversion of slider crank mechanism. Rather than in reciprocating engine where the cylinder is fixed, here the cylinder oscillates. This is known as oscillating cylinder. Oscillating cylinder engine, another inversion. So you should all get the names of these inversions of slider crank mechanism, and we should only go in detail about two, that is crank and slaughter and Whitworth quick return. This is known as oscillating cylinder. Cylinder reciprocates and piston oscillates and cylinder oscillates. And the third one that we need to go in detail is known as crank and slotted mechanism. We have already seen the video of this crank and slotted mechanism used in shaping machine where it is attached to the tool head. Tool is given the movement using the crank and slotted mechanism used in shaping and slotting machine. Slotting means vertical machine, shaping means horizontal machine. That's all. Shaping operation takes place horizontally, whereas slotting takes place vertically. The next inversion is Whitworth quick return mechanism. This is also we need to understand. Whitworth quick return mechanism used in planing machine, and this is used to move the workpiece or the workbench of the planing machine. Crank and slotted was used to move the tool of shaping, whereas this is used to move the workpiece of the planing machine. And there is also one more inversion that we call rotary engine. Basically, the inversion of slider crank mechanism itself. A rotary engine, that means piston will be rotating in 5 or 6 cylinders. Here it is all given as 5, but sometimes it is 6 cylinder also. A rotary engine. A crank rotates about the center and the piston cutting rods are attached in each end of the periphery of that crank circle, and they will make a reciprocating action. This was basically used in propeller driven aircraft. There is one then we need not go into detail of the third kinematic chain, but still to satisfy your curiosity, I'm just showing you animation of double slider chain mechanism. Okay, double slider. There is something called 4-bar slider crank and double slider. We only need 4-bar and slider crank, but still we will see what is a double slider mechanism. First one is elliptical trammel that will draw an ellipse from its edge. Elliptical trammel. There will be two sliders here, double slider, because two sliding pairs will be there. In 4-bar there was four turning pairs. In slider crank there was three turning and one sliding pair, and in double slider crank there will be two sliding pairs and two turning pairs. So first one is elliptical trammel that will draw an ellipse around it by making the slider move in cross direction in two grooves cut perpendicular to each other. That is known as elliptical trammel. You should learn the name. Second one is known as Scotch yoke mechanism used to draw simple harmonic motion. This is basically used in simple harmonic motion or drawing sine waves and cos waves like that. The perfect example for simple harmonic motion, Scotch yoke mechanism. This is also inversion of double slider mechanism, Scotch yoke mechanism. And other one is Oldham's coupling. Oldham's coupling. This is a dissectional view of Oldham's coupling. You will learn this Oldham's coupling in machine drawing if you have not learned already. Oldham's coupling. So you see, you can connect two parallel shafts which are not at same line of action with this Oldham's coupling. You can transfer the rotating motion to one shaft to other which is not in the same line of action but parallel to each other using Oldham's coupling. We have seen what is Hooke's joint, which is used to transmit power between two non-parallel intersecting shafts. This is two parallel non-intersecting shafts. So if you have a question like which kind of mechanical element is used to connect two non-parallel intersecting shaft usual answer should be universal joint or a Hooke's joint that we learned in the last session. But if there is two parallel which are non-intersecting shaft, then we can use this Oldham's coupling, which is a inversion of double slider mechanism. Two non-parallel shaft which are not intersecting. Oldham's coupling. I hope this is clear to you. So just to revise back what you have learned from the beginning, 4-bar mechanism. First, it's first inversion beam engine. Second inversion, sorry, first inversion coupled locomotive. Second inversion beam engine. Third inversion pantograph. Fourth inversion Watt's mechanism. This we have covered already in the second or third lesson. Then today we learned what is slider crank mechanism. First inversion was reciprocating engine. Basic slider crank mechanism itself is the first inversion. Second inversion is hand pump, which we learned just by this animation. We're not going to detail or draw any figures of hand pump. Then the one that is important to us, the third inversion, is oscillating cylinder engine. Still, we only need to learn the names of that. Then we learned what is crank and slotted quick return mechanism. Crank and slotted quick return. We should draw in detail and we should learn in detail about crank and slot, because basically used in machine tools in shaping and slotting machines. Forward stroke is to cutting stroke, it is long, whereas return stroke is quick, which is the idle stroke. Then we learned what is quick Whitworth quick return mechanism, basically another quick return mechanism in which used to in planing machines to connect it to the workpiece, where workpiece moves forward in cutting stroke and return in idle stroke. Then we see what is rotary engine, which is also another inversion of slider crank mechanism. Then we saw what is a double slider chain mechanism. You should not go in detail. First one is elliptical trammel, which draws an ellipse with its edge, elliptical trammel. Then Scotch yoke mechanism. Scotch yoke mechanism. Last one is Oldham's coupling. Oldham's couplings are used to connect parallel non-intersecting shafts to transmit power. Parallel non-intersecting shaft are used to, Oldham coupling is used to connect parallel non-intersecting shaft, whereas Hooke's joint is used to connect non-parallel intersecting shaft. So we will stop with this. So at this end of this session, you should draw what is like basic slider crank mechanism, what are the different links attached to it. You should draw a basic slider crank mechanism. Then you should draw crank and slotted mechanism. Then you should draw a Whitworth quick return mechanism. You should mention briefly how it's working, what are the angles, and you can submit your lecture note. Thank you.